Hello, today I would like to solve the problem of orthographic projection for octahedron. So the problem is a regular octahedron has one of its axes of symmetry vertical with one of its vertices on the HP at a distance of 60 mm from the VP. The square base which bisects the axis has one of its edges making 30-degree angle with the VP. The edges of the octahedron are 40 mm in length. Draw the top view, the front view and the left hand side view of this octahedron in the first angle projection system. So first of all, I would like to show you the solid, how octahedron looks like. So this is a model of octahedron. So here you can see that it has got faces. Each face is an equilateral triangle. So that means the sides are equal and all the faces are same in size. And there are 8 faces. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 equilateral triangles making this 3D shape. The base which is here is in a square. So you can see that this is in a square, but all the faces are equilateral triangle, and these are called vertices or vertex, or connecting two opposite vertices will form the axis. So there will be one axis, another axis and another axis here. These are called edges of this octahedron. So this is an example of what is known as plutonic solids. So there are 5 types of plutonic solids: tetrahedron, cube, octahedron, dodecahedron and icosahedron. So these are 5 types of platonic solids, and octahedron is one of them. Here you can see that all the axes are same in length. The faces meet at the vertices and make the same angle. So this vertex is same as this vertex. So this shape is completely symmetric. So this is the shape, and we are going to draw orthographic projections of this shape. So the problem says that a regular octahedron, so this is a regular octahedron, has one of its axes of symmetry vertical. So let's say this axis, we call it OP, is vertical, and one of the vertices or this vertex is on the HP. So this vertex is 60 mm from the VP. So if we imagine VP is here, so this vertex is 60 mm from the VP. All the edges are 40 mm in length. So we will draw the top view, the front view and the left hand side view in the first angle projection. So these kind of octahedrons are available in the nature. So for example, you can see some of the minerals are octahedron in shape. You also must have studied in chemistry about the solid structures like BCC, FCC. So for example, FCC has got a cubic structure, and on the faces of this cube, if you connect those points, the center point of each face, then it makes octahedron. Similarly, there are many chemical structures which are in octahedron. For example, sulfur, hexafluoride, and the mineral just now I showed you, fluorite, is octahedron in shape. So these are the kinds of shapes we can see in the nature. So it is very important that we understand about the shape, and also let us learn how to plot or how to draw the orthographic projection. So we will start with the reference line XY. So this is the center line, so we will draw as center line. Now one of the vertices is on the HP and 60 mm from the VP. So that means this point, which is the vertex, is 60 mm from the vertical plane. So therefore it will be 60 mm down from the reference line, because we are drawing in the first angle projection system. So we will mark a point at 60 mm from the reference line. So this is the position of the vertex. So here we can write O and P, because this will be the top view of both vertices, O and P. Here we can see O and P. Now the edges are 40 mm, but we have to draw this square, and we have to draw this square such that the edges of the square makes an angle of 30 degree with the vertical plane. So one of the edge makes 30 degree with the vertical plane, so it is slightly rotated like this. So first of all, we should find out the diagonal of this square. So diagonal of this square can be given as root 2 multiplied by a, where a is the length of the edge. So basically we can do the small calculation, root 2 multiplied by a. So root 2 is 1.414 multiplied by a, which is the length of the edge, is 40. So this makes 56.56 mm. So this is the diagonal. So the radius of the circle we will draw is half of this, so 28.28. So we will use this radius and we will draw a circle. So the square is within this circle. Now since the octahedron is slightly rotated like this, that means we have to find out the orientation. So first we will draw a line at 30 degree to this central line. Now we will draw all the construction line as thin line. So this is at 30 degree, and with this as 30 degree we will draw two lines at 45 degree to this line. So this basically we have got one of the side of this square. So these are the outlines of the top view. So therefore I am drawing a little bit thicker line. So this is inclined here, and this is the top view. So in the top view we will also see these edges. We will see this square, these edges. But in the top view we cannot see these edges because these are hidden and they are overlapping with each other. So we do not have to draw the dotted line for these hidden edges. So as I said just now, in this top view we will see this square which is oriented in such a way that one of the edge makes 30 degree angle with the VP, and we are able to see these edges in the projected form, but these edges are not seen because they are hidden and they are overlapping with each other, so we do not have to draw those dotted lines. So now we will draw the front view of this solid. Now since the vertex is on the HP, so therefore we will start the front view from here, from the reference line, and the length of this axis is same as the diagonal because it is a symmetric shape, so this length is same as the diagonal of this square. So these are the points P. So we will write as P dash because this is the front view, and this should be small p because this is the top view, and this is O dash. Now we need to find out the midpoint of these O dash P dash. So for midpoint we can just use our geometric calculation. So this is the geometrical way of finding out the midpoint. So in the front view, this square will come here, and basically we already have the projections, so all we need to do is to draw thick line here. So if these points are A, B, C and D, then this will be A dash, this will be D dash, B dash and C dash. So already we have the vertices O dash, P dash, and then these vertices. So now we will connect them. So when we are looking in the front view, these edges are visible. So OA and AP are visible. Similarly, OB and BP are visible. But the edges which connect to this vertex is not visible because it is behind. So accordingly we will draw these lines. So these edges are visible. Then OB and BP are also visible. But O dash D dash is not visible. So therefore we will draw dotted lines. Similarly, this edge is also not visible. So this is the front view and this is the top view. So now we will make the left hand side view on the right hand side. So first we will draw some construction lines. Before that we can also draw a line at 45 degrees. This is a way of projecting the dimensions from the top view to the side view. Now we should project the dimensions from the front view. So this one is already projected. So now we have projected all the points, so we should identify the points. So basically we are looking from the left hand side and we are projecting it on the right hand side. So first let's identify the points. So for example, this is A, B, C, D, and O and P. So these are the points, and we have to see which are visible in the left hand side. So in the left hand side view, the edge connecting OA and AP will be visible. So OA and AP. Then the edge connecting DOD and DP will be visible. And first of all, we should also draw this as thick line. Another edge which will be visible is OB and BP. Now the edge OC and CP will not be visible in the left hand side view, so therefore this will be hidden line or dotted line. Similarly, CP. So since this is a very symmetric shape, so we can see that the front view and the side view look quite similar. So this is the way we can draw the orthographic projections of octahedron. So let's do the dimensioning. So in dimensioning, we only dimension the lengths or the dimensions which are given. So for example, the edge length is given, which is 40 millimeter. Also the location of one of the vertices is given, which is 60 millimeter. So these two dimensions are given, so we will dimension them here. We will not dimension the diagonals because diagonals are not given, these are derived. And similarly the length of the axis is also not given. So this is basically the same as the diagonal. So this is the top view, the front view and the side view. So thank you very much for watching this video. In the next video, I would like to show you how to draw the isometric view of octahedron and also how to draw the development of octahedron. So thanks a lot. If you have any question or comment, please do write them down below in the comment section. Thank you.